So thank you, Neeraj sir. So welcome friends, welcome you all in the another lectures of All India Council Technical Education sponsored Prerna scheme. Myself, Professor Asif Beg, Assistant Professor, Civil Engineering Department, to Gaikwad Patil College of Engineering and Technology, Nagpur, an autonomous institute and accredited NAC with A plus grade. So today in the lecture we will discuss about which we will see what is mean by the duty, delta, estimation of evapotranspiration, crop water requirement, design of lined and unlined canal, headworks, gravity dams, and the spillway. So likewise, we have this much of content for the today's lecture, and today we will discuss all these things in the today's presentation itself. Okay, so let's begin with the definition of irrigation. Irrigation is an artificial application of water to the soil. So normally, what happen actually? Uh, for growth of the crops or for the irrigation purpose, we require the water, and we cannot totally rely on the rainfall, because rainfall have a particular season for 4 months only, but we have to grow the crops for entire year for all the 12 months. So that's why we have to store the water artificially or in any other form, and that we have to provide to the soil for the growing of the crops. So it usually used to assist the growing of the crops in dry areas and during periods of inadequate rainfall. So what is the need of the irrigation? So India is basically an agricultural country, and all the resources depend on the agriculture. And you can heard the Nara, that is Jai Jawan and Jai Kisan. So two pillars we can say of the India of the nation is farmer, and other one is the army. So farming, we have the 70% of the agricultural, uh, we depend on the agriculture. So water is eventually the most vital element in the plant life, and water is normally supplied to the plants by nature through rains. However, the total rainfall in a particular area may be either insufficient or ill-timed. Systematic irrigation system collecting water during the period of excess rainfall and releasing it to the crop when it is needed. So why there is less rainfall, so artificially supply is necessary, and irrigation work may be constructed at a place where more water is available and then convey the water where there is less rainfall. So what can be done in the case of this irrigation system? When where the rainfall is happening very less, at this place we can provide the water through the canals or any other form, by raising the water at when at where the water is available at in the sufficient way. Okay, so in the form of dam construction or the weir construction or any other form, we can raise the water and we can store the water, and we supply that water to the area where the less rainfall is occurs. Okay, now at non-uniform rainfall, so this is the another need of the irrigation. When the uniform is not when the rainfall is not uniform, so rainfall may not be uniform over the crop period in the particular area. Sometimes some crops are required the uniform water for the growing for the growth of the crops. So for the uniform supply of the water, we require these irrigation schemes. And rain may be available during the starting period of the crop, but no water may be available at end. With the result, yield may be less or crop may be die. So collection of water during the excess rainfall and supplied to the crop during the period when there may be no rainfall. So commercial crop with additional water is the another requirement of the irrigation. That is, rainfall may be sufficient to raise the usual crop, but more water may be necessary for raising commercial and the cash crops. So as we have the sugar cane, tea, tobacco, cotton, cardamom, and indigo, these crops are required more water. Okay, now controlled water supply. So yield of crop may be increased by construction of proper distribution system. Now, what are the benefits of the irrigation? So it increase in the food production if the crops the water supplied to the crop is sufficient, then will be increase in the food production. Now, production from the famine, cultivation of cash crop like sugarcane, tobacco, and cotton, addition to the wealth of the country as the most reliable or most we can say reliable thing in the country is the agriculture. So that's why it will increase the wealth of the country, increase the pos- prosperity of the people, generation of hydroelectric power, domestic and industrial water supply, inland navigation, improvement of the communication, canal plantations, improvement in the groundwater storage, and general development of the country. So, irrigation is not only for the farming purpose, but it is also to generate the hydroelectric power. It is also used for the domestic and the industrial water supply. So, in all aspect, we have to store the water. This irrigation scheme is beneficiary. Now, what are the types of irrigation or the classification of irrigation? So, irrigation is divided into two classification: natural irrigation and artificial irrigation. Again, the natural irrigation is divided into two: rainfall and inundation canal system. So, this one is the natural classification of the irrigation. Now, in the artificial irrigation, it is divided into two: flow and lift irrigation. And again, flow irrigation is divided into four classification. One is the perennial irrigation, inundation irrigation, direct irrigation, and storage irrigation. So let's see one by one. First, we will see the natural irrigation. So no engineering structure is constructed. So as the name it's indicate itself that this is the natural irrigation, and hence there is no engineering structure is to be constructed for this natural irrigation. Now, first one is the rainfall irrigation, in which the rainfall is only used for raising the crops, and in inundation canal system, flood water is utilized for irrigation purpose by properly directing the flow of water. So when there is excess water rainfall at somewhere, so we have to use a proper channel, and we have to direct that channel or flooded water to the area where the water is happening very less. Okay, so this is the inundation canal system. Now the artificial irrigation requires the engineering structure, and the proper designing of the engineering structure have to be constructed. Now, first one classification is the flow irrigation, in which the water flows to the irrigated land by gravity. So there is no additional equipment for pressurizing the water or the pumping the water is required. So through the gravity, the water flows to the irrigated land, and water resources is to be higher level than the irrigated land. So as we have to use the gravity for using this flow irrigation, it it may be possible when the water source is to be higher level, with with higher level than the irrigated land. Now, the first classification under the flow irrigation is perennial irrigation. So, water is supplied according to the requirements throughout the crop period through storage canal headworks and canal distribution system. Now, in inundation irrigation, lands are submerged and thoroughly flooded when flood occur in the river. Lands are allowed to drain off and crop are sown. Now the soil retains sufficient moisture for the crop to grow. Direct irrigation, water is directly diverted to the canal from the river is called direct irrigation. Discharge in the river shall be higher than the water requirement during the crop period. A low diversion weir or a barrage is constructed across the river to raise the water level and divert the same to the canal. Direct irrigation can be adopted only where there is enough flow in the river to provide sufficient quantity of water required for irrigation throughout the crop period. Now, storage irrigation, in which we have to use the river flow, is not perennial or insufficient during the crop period. Storage irrigation sorry Storage irrigation is adopted. A dam is constructed across the river to store the water in the reservoir. In some area, rainwater that run off from the catchment area is stored in tanks and is used for irrigation during the crop period. So storage irrigation is nothing but to prepare the dam across the river, or we have to raise the weirs, or sometimes it is to be storage in the tanks, and afterward which we have to be used. So this is nothing but the storage irrigation. Now lift or the well irrigation, water is lifted up by the mechanical such as pump, etc., or manual to supply for irrigation. Lift irrigation is adopted when the water source is lower than the level of lands to be irrigated. So lift irrigation or the well irrigation is nothing but the water which is to be lifted by the mechanical machine like a pump, and or sometimes it is to be manually uplifted through the um, from the well irrigation. Okay, now the historical development of the irrigation. In the historical development of the irrigation, uh, civilization have been dependent on the development of the irrigated agriculture. Archaeological investigations has identified evidence of irrigation in Mesopotamia, ancient Egypt, and ancient Persia, at present, which is called as Iran, as far back as 6th millennium BCE. Now, in the Zana Valley of the Andes Mountain in Peru, archaeologists found remain of three irrigation canals radiocarbon dated from the 4th millennium BC, the 3rd millennium BC, and the 9th century CE. These canals are the earliest record of the irrigation in the New World. The Indus Valley civilization in Pakistan and North India from 2600 BCE also had an early canal irrigation system. Large scale agriculture was used for the purpose of irrigation. There is evidence of ancient Egyptian Pharaoh Amenemhet III in the 12th dynasty, about 1800 BC, using the natural lake of the Oasis as a reservoir to store surpluses of water for use during the dry season. The lake swelled annually from flooded of the Nile. The irrigation work of ancient Sri Lanka, the earliest dating from about 300 BC, in the region of King Pandu Kambaya, and under condition development for the next 1,000 years. One of the most complex irrigation system of the ancient world. In the Sichuan region, ancient China, the Jiangyan irrigation system was built in 250 BC to irrigate a large area, and it still supply the water today. In the America, extensive irrigation systems were created by numerous groups in uh, prehistoric times. One example is seen in the recent archaeological excavation near the Santa Cruz River in the Tucson, Arizona. They have located a village site dating from 4,000 years ago. Now, present status of the irrigation. So, this is all about the historical development of the irrigation. You can see the 3rd millennium BC, the 9th millennium BC, the century BC. This is all about the history of the irrigation. Now moving toward the present status of the irrigation. In the middle of 12th century, the advent of diesel and electric motors led for the first time to system that could pump groundwater out of major aquifers faster than it was recharged. This can be lead to permanent loss of aquifer capacity, decreased water quality, ground subsidence, and other problems. The largest contiguous area of high irrigation density are found in North India and Pakistan along the river Gangas and Indus. In the Hai Huang, He and Yong's basin in China, along the Nile River in Egypt and Sudan, in the Mississippi Missouri River basin, and in part of California. Development aspect of the irrigation. Irrigation is practiced to maintain the different developmental parameters. Those are to make up the soil moisture deficit, to ensure a proper and sustained growth of crops, to make harvest safe, to colonize the cultivable wasteland for horizontal expansion of cultivation, to shift from seasonal cultivation, to promote more intensive cultivation by multiple cropping, to improve the level of agricultural productivity by acting as an agent for adoption of modern technology, to lessen the regional and size class inequalities in agricultural productivity that will reduce in turn socio-economic imbalance. Now, moving toward the advantages of the irrigation. So, no doubt there are many advantages of the irrigation which can be direct as well as indirect. So, first we will see the direct benefits. The direct benefit of the irrigation are the grower has many choices of crops and varieties and can go for multiple cropping for cultivation. Crop plants respond to fertilizer and other inputs and thereby productivity is high. Quality of the crop is improved. Higher economic return and employment opportunity, it makes economy drought proof. Development of pisciculture and afforestation. Plantation is raised along the banks of canal and field boundaries. Domestic water supply, hydel power generation at dam site and means of transport where navigation is possible. Prevention of damages through the flood. Now moving toward the indirect benefit, which increase in gross domestic product of the country, revenue, employment, land value, higher wages to the farm laborers, agro-based industries, and the groundwater storage. General development of other sectors and development of the country, increase of the food production, modify soil or the climate environmental leaching, lessen the risk of catastrophic catastrophic damage caused by a drought, increase income and national cash flow, increase labor employment, increase standard of living, increase value of land, national security, thus self-sufficiency, improve communication and navigation facilities, domestic and industrial water supply, improve groundwater storage, generation of hydroelectric power. So this is all are the advantages in the form of direct and indirect irrigation advantages. Now moving toward the disadvantages of the irrigation. The following are the disadvantages of irrigation as these are the very less. So waterlogging may be happen by storing the water, salinity and alkalinity of the land, ill aeration of the soil, pollution of the underground water, result in colder and damper climate causing outbreak of the disease like malaria. So these are the few disadvantages in the irrigation and which can be accumulated by using proper treatment. Okay, now moving toward the types of crop. So first one is the wet crop, which lands are irrigated and then crops are cultivation. Dry crops which do not need irrigation, garden crops which need irrigation throughout the year, summer crop kharif which are sown during the southwestern monsoon and harvested in autumn, winter crops that is rabi which are sown in autumn and harvesting in spring, cash crop which has to be encased in the market as it cannot be consumed directly by the cultivators. So these are the types of crop which require different types of irrigation time to time. So on the basis of crop, when it is to be sown and when it is to be harvested, that we will see. So kharif crop, that is some summer season crop having rice, maize, bajra, jawar, pulses. So these are the summer season or the kharif crops which sown in June or July and harvested in October to December. Okay. Now moving toward the rabi crops, that is the winter season crops in which wheat, peas, barley, gram, tobacco, potato are to be um, produced and which is to be sown from October to uh, November month or sometime it is February or March and cultivated in March or April and whatever the tobacco is sown in February or March, it is to be sown in June. Okay. So likewise, we have 8 month crop cotton, which is sown in May or June, and crop harvested in December or January. Now, annual crop sugarcane, that is February or March, it is to be sown, and December to March, it is to be harvested. Now, what are the crop seasons? So, in North India, the crop seasons is divided into two, that is Rabi and Kharif. So Rabi crops are called as winter crops and Kharif crops are called as summer crops. Kharif crops require more water than Rabi crops. Rabi start from 1st October and ends on 31st March. In Tamil Nadu, crops are classified as wet and dry crops. Now, we will see the crop rotation. So rotation of crops implies the nature of the crop sown in the particular field in changed year after year. The necessity of for this rotation is the necessity for irrigation when the same crop is grown again and again in the same field. The fertility of land gets reduced as the soil becomes deficient in plant food favorable to the particular crop. If different crop were to be raised here, would certainly be more balanced fooding and soil deficient in one particular type of nutrient is allowed to recouped. Now, crop disease and insect pest will multiply at an alarming rate. If the same crop is to be grown continuously, rotation will check the disease. A leguminous crop, that is gram, if introduced in rotation, will increase nitrogen content of the soil, thus increasing in the fertility. The deep rooted and shallow rooted crops in rotation draw their food from different depths of soil. The soil will be better utilized. Rotation of crops is beneficial to the farmer as there would be rotation of cash crops, fodder and soil renovating crops. General rotation of crops can be summarized as wheat, great millet gram, rice gram, cotton wheat gram, cotton, wheat, sugarcane, cotton, wheat, millet, gram. So this is the rotation of the crops can be summarized. Okay, so first we have to sow and harvest wheat. Then we have to sow the great millet, and then we have to after harvesting this we have to sow the gram. So this is the cycle for crops. Okay, so this likewise we have to rotate these three types of crops in a year. Now, consumptive use of the water. Considerable part of water applied for irrigation is lost by evaporation and transpiration. These two processes, being difficult to separate, are taken as one and called vapor transpiration or consumptive use of water. Now, what is meant by duty? What is meant by delta? That we will see. So, duty is nothing but the area of the crop irrigated divided by volume of the water required. So, what is duty? Suppose we have 1 hectare area for the irrigation land, and that 1 hectare required whatever amount of water in the volume, that is, if you have calculated that, that is nothing but the duty. Now, what is meant by the delta? So, delta, the depth of the water required every time, generally varies depending upon the types of the crops. Now, the total depth of water required crop to nature is called delta. Crop period, the what is crop period? The time from the instant of its sowing to the instant of harvesting, this is the crop period. The time from the sowing to the harvesting, that is the crop period. Now, base period, the time between the first supply of water to the land and the last watering before the harvesting. So this is the base period. Now, what are the factors affecting the duty? There are many factors which affects, out of which one very important factor is the soil moisture. So in clay soil, less water is required since its retentive capacity is more. The pervious soil, it will be more, and topography is another factor which affect the duty, in which the uniform distribution depend on the topography. If the area is sloping, the lower portion will get more water than the flat portion, and hence water requirement is increased. Now, the nature of rainfall. If rainfall is high over the crop period, water requirements become less. Otherwise, it will be more. Now, nature of the crop irrigated is dry crop requirement less water, whereas wet crop require more water. Now, this is a spell typing mistake. Actually, this is wet crop require more water. Now, method of cultivation, the fifth factor which affect the duty. If the field are properly ploughed, it will have a high retentive capacity and the number of watering are reduced. Now, season of crop. Less irrigation water is required for rainy season crop and the duty increased. If the crop grown in summer, more irrigation water is required and duty gets decreased. Now, system of irrigation is also affects the duty. In perennial irrigation, continuous supply of water is given and hence water table is kept high and percolation uh, percolation losses is minimized. Now, in undulation type of wastage is more by deep percolation. Now, canal condition. Well maintained canal will have more duty as the losses is very less. Now, improving duty. How we have to improve the duty? The water losses, whatever the factor which we have seen in the factor affecting the duty, if we concentrate on that particular factor, we can improve the duty. The water losses can be reduced by having the irrigated area nearer to the head of the canal. Evaporation losses can be minimized using the water as quickly as possible. Water losses can be minimized by lining the canal. The cultivators should be trained to use water economically without wasting. The soil properties should be studied by establishing research station in the villages. Now we will discuss about the crop period and the base period. Now, what is crop period and base period? We have already seen the time period that elapses from the instant of its sowing to the instant of harvesting is nothing but the crop period. The time between the first watering of the crop at the time of its sowing to its last watering before harvesting is called the base period. Now, duty and the delta of a crop delta, the total quantity of water required by the crop for its full growth may be expressed in hectare meter or simply as depth to which water will stand on the irrigated area. If the total quantity supplied were to stand above the surface without percolation or evaporation, this total depth of water is nothing but the delta. So, on the basis of delta, we having some numerical. So, this type of question may be asked in the examination if the rice require about 10 centimeter depth of water at an average interval of about 10 days and the crop period for rice is 120 days. Find out the delta for rice. So number of watering required 120 divided by 10. So for each 10 days we have to do the watering for 10 centimeter for continuous 120 days. So 120 days divided by 10. So 12 time I have to do for 10 centimeter rice. So total 10 into 12 multiplied by 120 centimeter. So delta for rice is 120 centimeter. Now problem 2, that is if wheat require about 7.5 centimeter of water after every 28 days and the base period for wheat is 140 days, find out the value for delta for wheat. So we have after every 28 days we have to do the require the 7.5 centimeter water for 140 days. So 140 days divided by 28, we will have the value as 5. This 5 multiplied with 7.5, so we will having the value as 37.5 centimeter will be the delta for wheat. Now, what is meant by the duty? So, duty it may be defined as the number of hectares of land irrigated for full growth of a given crop by supply of 1 meter cube per second of water continuously during the entire base of that crop. Now, simply we can say that the area in hectares of land can be irrigated for crop period B in days using the 1 cubic meter of the water. So, what are the factor affecting the duty depends on the type of crop, climate and the season, use of the rainfall, or type of the soil or the efficiency of the cultivation method. Now, importance of the duty. Why the duty is important? So it helps us in the designing an efficient canal irrigation system. So for storage irrigation or for the artificial irrigation, we have the duty is important. Now, knowing the total available water at head of the main canal and the overall duty for all the crops required to be irrigated in different season of the year, the area which can be irrigated can be worked out. Inversely, if we know the crops area required to irrigate it and their duties, we can work out the discharge required for designing the channel. Now, what are the measures for improving duties of the water? The duty of canal water can certainly be improved by effective economy in the use of water by resorting to the following precautions and the practices. So, what precautions and practices which we have to adopt for improving the duty of the water? Now, proper plugging. Now, plugging should be done properly and deeply so that the moisture retaining capacity of the soil is increased. Now, the second precaution which we have to take, or the practice we have to ensure, that is the method of supply of water. The method of supply of water to the agricultural land should be decided according to the field and soil condition. For example, furrow method for crops sown iron row, contour method for hilly area, basin for orchards, flooding for plain lands. Now, canal lining, it is provided to reduce the percolation loss and the evaporation losses due to the high velocity. Now, minimum idle length or irrigation canals, it is also one of the factor which can be increase the duty of water. So the canal should be nearest to the command area so that idle length of the canal is minimum and hence reduce transmission losses. Now, the quality of water, a good quality of water should be used for irrigation. Or the pollution in the root, the canal should be avoided. Now, crop rotation. The principle of crop rotation should be adopted to increase the moisture retaining capacity and the fertility of the soil. So, the crop rotation we have seen in the earlier slides, that can be followed to increase the duty of the water. Now, the consumptive use of the crops. So, what is the definition of this consumptive use of crop? It is the quantity of water used by the vegetation growth of the given area. It is the amount of water required by a crop for its vegetated growth to evapotranspiration and building the plant tissues, plus evaporation from soil and intercepted precipitation. It is expressed in terms of depth of water. Consumptive use varies with temperature, humidity, wind speed, topography, sunlight, hours, method of irrigation, moisture availability, and mathematically it can be used. It can be written as consumptive use is equals to evapotranspiration is equals to evaporation plus transpiration, and it is expressed in terms of depth of water. Now, factors which affects the consumptive use of water. So, consumptive use of water varies with evaporation, which depends on humidity, mean monthly temperature, growth season, growing season of crops and cropping pattern, monthly precipitation in area, wind velocity in locality, soil and topography, irrigation practices and method of irrigation, sunlight hours. Now, types of consumptive water use. Following are the types of consumptive use, that is the optimum consumptive use, potential consumptive use, and the seasonal consumptive use. Now, one by one, we will see this type of consumptive water use. Now, optimum consumptive use, it is the consumptive use which produces a maximum crop yield. The second one is the potential consumptive use. If sufficient moisture is always available to completely meet the need of vegetation, fully coverage the entire area, then resulting evapotranspiration is known as the potential consumptive use. Now, seasonal consumptive use is nothing but the total amount of water used in the evapotranspiration by the cropped area during the entire growing season. Now, crop water requirement. So, what are the crop water requirements? So, first one is the soil moisture. So, classes and availability of soil water is water present in the soil may be classified under three heads: hygroscopic water, capillary water, and the gravitational water. So, in the figure, you can see here, this is the hydroscopic water at the bottom, which is not available water. So after non-available water, this is the capillary water, which is available, and super flows water, that is the gravitational water. So this is the depth of water we can say. So uh, we will move to the hygroscopic water. So hygroscopic water is nothing but the water attached to soil particle through losses, chemical bonds, is termed hygroscopic water. This water can be removed by heat only, but the plant roots can use a very small fraction of the soil moisture under the drought condition. Now, the capillary water is held within soil pores due to the surface tension forces against gravity, which act at the liquid vapor or water air interface. Now, gravitational water is that water which it drains away under the influence of gravity. Soon after irrigation or rainfall, the water remains in the soil and structure of the soil, uh, saturate the soil, thus preventing circulation of the air in the void space. Now, available moisture for the plant we can see here in the diagram. Okay, now this is the impervious strata, this is the groundwater here, so this is the roots, this is the soil zone or the root zone. Okay, now this is the intermediate zone and this is the capillary water, so this is the soil moisture we have. Okay, and this is the water table. So in the graph of the time versus moisture content, you can see here, uh, this is the non-available or hygroscopic water at the bottom, and this is whole is the field capacity, and above the non-available or the hygroscopic water we having the available or the capillary water, and at this point this is the dotted point, this is the wilting point. Okay, and this is the field capacity. Now, similarly, we have again the another curve in which the available moisture is shown and the optimum moisture content is also shown. Okay, now the readily available moisture for the plant is equals to Fc minus Mo, where Fc is nothing but the field capacity and phi is nothing but the wilting point or the wilting coefficient below the plant can't survive. Now, Mo is nothing but the readily available moisture content. Now, frequency of the irrigation, weight, or the readily available moisture depth divided by consumptive use of rate. Now, Fc is equals to weight of the water stored in soil of unit area, weight of the subsoil of the unit area. Now, here weight of the water stored in soil unit area is nothing but the gamma W into dW into 1. Weight of this is not 1, this is L. So weight of the some soil of unit area gamma dl, where dw is nothing but the depth of water stored in root zone. So dw is calculated by gamma into d divided by gamma w fc into fc, where gamma is the dry unit weight of the soil. Now, available moisture depth to plant is nothing but dw is equals to gamma d divided by gamma w into fc minus 5. Readily available moisture depth to plant dw is equals to gamma d divided by gamma w into fc minus m0. Fc is equals to n divided by g, where g is the specific gravity and n is the porosity. So these all are the equation which can be used, or on the basis of this equation, the question may be asked in the gate examination to calculate the available moisture depth, or to calculate the soil of weight of the soil. So these things which we have to be calculated in the numerical. Okay. Now we will discuss about the duty and delta. So the duty of water is the relationship between the volume of the water and the area of the crop it matures. Now, it is defined as the area irrigated per cubic of discharge running for based period B. The duty is generally represented by D. So, delta it is the total depth of water required for by a crop during the entire base period and is represented by the symbol del. Now, relation between the duty and delta, so del is equals to 8.64 B divided by D. So, this equation you have to remember. Okay, so what is the relation between the duty and the delta? So, delta is equals to 8.64 B divided by D, where del is delta in meter, D is duty in hectare per cubic, and B is the base period in the days. So also we have del is equals to 2B divided by del. So delta in meter, B is base period, and D is duty in acres per cure, cumex. Okay. So again there is a typing mistake here. Now, irrigation requirement of the crops. So, consumptive irrigation requirement CIR is equals to CU minus P, where CU is the total consumptive use requirement and P effective is nothing but the effective rainfall. Now, net irrigation requirement NIR is equals to CIR plus leaching requirement, and Field irrigation requirement FIR is nothing but the FIR divided by NIR divided by NA. Gross irrigation requirement GIR is nothing but the GIR divided by FIR divided by NC. So this equation you have to remember for solving the question to calculate gross irrigation requirement, field irrigation requirement, net irrigation requirement, or consumptive irrigation requirement. So these four equations are there on the basis of which the question may be asked in the GATE examination. Now, methods of determination of evapotranspiration. The measure or estimation the consumptive use, there are three main methods: direct method or field method, empirical methods, pan evaporation method. Now, direct methods. In this method, field observation are made and physical model is used for this purpose. This includes vapor transfer method, soil moisture studies, field plot method, tanks and lysimeter, integration method, summation method, irrigation method, inflow outflow method. Now, vapor transfer method, we will go one by one. In this method of estimation of water consumptive use, soil moisture or the soil measurement are taken before and after each irrigation. The quantity of water extracted per day from soil is computed for each period. A curve is drawn by plotting the rate of use against time, and from this curve, the seasonal use can be estimated. This method is suitable in those areas where soil is fairly uniform and groundwater is deep enough so that it does not affect the fluctuation in the soil within the root zone of the soil. So it is expressed in the terms of volume, that is acre per feet or the hectare per meter. Now, field plot method. We select a representative plot of area and the accuracy depend upon the representativeness of plot, cropping intensity, exposure, etc. It replicate the condition of an actual sample field. Field plot, less seepage should be there. So inflow plus rain plus outflow is equals to evapotranspiration. Now, the drawback in this method is that lateral movement of water takes place, although more a representative field condition. Also, some correction has to be applied for deep percolation as it cannot be ascertained in the field. Now, tanks and lysimeter. In this method of measurement of consumptive use of water, a watertight tank of cylindrical shape have diameter 2 meter and depth about 3 meter is placed vertically on the ground. The tank is filled with the sample of soil. The bottom of the tank consists of sand layer and the pan for collecting the surplus water. The plant's growth in the lysimeter should be the same as in the surrounding field. The consumptive use of the water is estimated by the measured the amount of water required for the satisfactory growth of the plants within the tank. The consumptive use of the water is given by Cu is equals to Wa minus Wd, where Cu is nothing but the consumptive use of water, Wa is water applied, and Wd is water drained off. Now, lysimeter studies are time consuming and expensive. Method 1 and 2 are the more reliable methods as comparative to the methods. Now, integration methods. In this method, it is necessary to know the division of the total area, that is the under irrigated crops, natural native vegetables, vegetations area, water surface area, and bare land area. In this method, annual consumptive use for the whole area is found in the terms of volume. It is expressed in acre feet or the hectare meter. So mathematically, it is to be written as total evapotranspiration is equals to total consumptive uses. Now the area annual consumptive use is equals to total evaporation. Evapotranspiration is equals to A plus B plus C plus D. Now what are these A, B, C, D? So A is nothing but the unit consumptive use for each crop into its area. B is nothing but unit consumptive use of native vegetation into its area. Water surface evaporation into its area, and bare land evaporation into its area. Now, irrigation method, this is the fifth one. So, in this method, unit consumption is multiplied by some factor. The multiplication values depend upon the type of crops in certain area. This method require an engineer judgment as these factors are to be investigated by the engineers of the certain area. Now the next method, which is inflow outflow method. In this method, annual consumptive use is found for large area. If U is the value consumptive use, it is value is given by U is equals to in bracket I plus P plus GS minus G minus R, where U is nothing but the value consumptive use in acres, feet or the hectare. I is total flow during a year. P is yearly storage at the beginning of the year. GE is the ground storage at the end of the year, and R is the yearly outflow. Now, the second method is the empirical method. Now, in this method, empirical equation are given for the estimation of water requirement, and these are Blaney-Criddle method, Lowry-Johnson method, Penman equation, Hargreaves method. So these four methods that we will see one by one. Now Blaney and Criddle 1950 observed that the amount of water consumptively used by crops during their growth season was closely correlated with mean monthly temperature and daylight hour and the length of the growing season. The correlation coefficients are then applied to determine the ET for the other area where only climate data are available. Blaney-Criddle formula is one of the best known procedures for estimating potential evapotranspiration (PET) and is widely used. The popularity of the procedure is due to simplicity and its use of readily available data. It requires the use of only two factors, namely temperature, which is readily available from the weather station, and information in on daylight hours, which is a factor based purely on the latitude of the place. Now, Blaney-Criddle equation expresses the consumptive use in terms of temperature and daytime hour. If Cu is monthly consumptive use, its value is given by Cu is equals to Kf in inches, where K is crop factor to determine for each crop. Its value depend upon the certain environmental condition, where F is monthly consumptive use factor. So that is equals to T into P by 100, where T is the mean temperature in Fahrenheit. Now, P is the percentage of daytime hours of the year occurring during the period. If expressed in metric unit, the above formula becomes Cu is equals to K into P by 40 into 1.8 T plus 32, that is equals to K into F. So T is temperature in degree centigrade and Cu is the monthly consumptive use in the centimeter. So this is what this is the first method, and moving to the Lowry Johnson method, in which the equation is used as U is equals to 0.0015 H plus zero point 0.9. So U is nothing but the consumptive use and H is the accumulated degree days during the growing season computed from the maximum temperature about 32 Fahrenheit. Now moving toward the next, that is the Penman equation. So Penman 1948 proposed an equation for evaporation from open water surface based on a combination of energy balance and sink strength, which is given below with changes in certain symbols in view of the recent trends. According to this method, U is equals to ET, which is equals to A into H plus 0.27 E small a capital A minus 0.27, where ET is nothing but the evapotranspiration or the consumptive use in mm, EA is evaporation mm per day, H is daily heat budget at surface per day. H is a function of radiation, sunshine hours, wind speed, vapor pressure, and other climatic factors. A capital A is nothing but the slope of saturated vapor pressure curve of air at absolute temperature in Fahrenheit. Now the last method, that is the Hargreaves method. So it is very simple method. The pan in circular with a diameter of 1.2 meter and depth 255 mm, which gives it a volume of about 0.3 meter cube. The basin is put on a 150 high wooden frame due to air circulation around the basin. The water level is kept about 50 below the rim due to the allowance of the percolation and the need of water. Now, the water level is measured every day. Either you measure the difference between the present and the origin water level, or if you have chosen to obtain the water level in the pan, you measure the amount of the water you have put into the pan. Now, according to this method, Cu is equals to equation is given as Cu is equals to K into E into P, where Cu is nothing but the consumptive use coefficient, varies from crop to crop. And evapotranspiration, Ep is nothing but the evapotranspiration, and K is the coefficient. Now, at this moment, we have completed this topic. Now we will move towards the questions which is asked in the gate examination, and on the basis of that, we will have some question answer session. Okay, so let's move towards this. At this moment, I hope you have understood about all the irrigation factors. Okay, so let's move towards the irrigation segment of the question answer. This question is asked in the gate examination that we will see with the solution. The question is asked on the equation which we have seen in the today's class. Okay, so what we have to remember is you have to remember only the equation, okay, and the conditions. So on the basis of that, you can solve these 2 mark question in the gate examination. Now we will just directly go to the irrigation part. Okay. Now, this type of question, which we have already done in the previous classes of the hydrology, as well as we have done in the irrigation as well. So, this kind of question is asked that to calculate the basin with an area of 756 kilometer square has 6-meter unit hydrograph. So, this question was asked on the unit hydrograph, that topic we have covered yesterday. So, this kind of question is asked in the gate examination. You can just go through this. I will provide the this question answer to you. For by the help of this, you can easily can crack the gate examination. Okay, now this is the topic which we have covered today. So while applying the rotational formula for computing the design discharge, the rainfall duration is stipulated as the time concentration, because the time of the concentration is the largest rainfall duration for which the rational formula is applied. So D option will be the right answer. So this kind of question also asked in the gate examination, that also we can have a look on it. Okay, but we will only focus on the numerical part. Okay, so that's why I'm just skipping these theoretical things which can be easily you can get understand. Okay, now at the bottom. Okay, so this is duty delta estimation of evapotranspiration crop water requirement. So these things we have seen. Oh, so a tube well having a capacity of 4 meter cube per hour operates for 20 hours each day during the irrigation season. How much area can be command if the irrigation interval is 20 days and the depth of the irrigation is 7 centimeter? So we have to calculate the area in the lecture itself. We have calculated by using this equation. So volume of the water in 20 days is 4 into 2 into 20. So total 1600 meter cube volume is we have. So volume is equals to area into this 7 centimeters. So 7 centimeter divided into 100. We have converted this into meter. So area we have calculated as 2.29 into 10 to the power 4 meters square. Now similarly, the question may be asked on this to calculate the efficiency, that is a field was supplied water from the irrigation tank at a rate of 120 liter per second to irrigate an area of 2.5 hectares. The duration of the irrigation is 8 hours. It was found that the actual delivery at the field, which is about 4 kilometers from the tank, was 100 liter per second. The runoff loss in the field was estimated as 800 meter cube. The application efficiency in this situation is, so how we have to calculate is the water delivered to the field we have calculated as 2880 meter cube. This equation already we have seen in the lecture itself. So by using all these equation, as the we got the application efficiency as 72%. So B option will be the right answer for this. Okay. So similarly we have the questions on canals, we have the questions on duty, we have the questions on the calculation of delta, we have the questions on the calculation of the area required for the crop. Okay, so all these questions are asked in the GATE examination. We have the solved or the explanation of the right answer we have with us. So I will provide you all these things after this course, after the completion of this course. Okay, so at this moment we will stop here, and in the next class we will try to cover the part of irrigation, another topic of the irrigation. Okay, so thank you very much.
Yes, sir. Okay, sir.